Hello everyone and welcome to lesson 9.2.3. How can I find the side length? Now the key point to today is understanding square roots. Now it's not just being able to compute square roots. We want to understand what they are and how they operate. The more we understand something, the better we are at doing that thing. Now I want you to notice I wrote down the Pythagorean Theorem, okay? And I would really like you to write down the Pythagorean Theorem as well. For the last several lessons, we have been working on this relationship. Theorem. There we go. Mr. McCoy loves to spell. Now, when we are dealing with the Pythagorean theorem, we are dealing with the small square added to the medium square will equal the area of the large square. This is the relationship we've been working on for the last couple of days. And so in this problem, what am I missing? Your eye should tell you that that square is the smallest square. So I am missing the small square. I know the medium square is 16. And I know my large square has an area of 20. And so as I think about this math, what plus 16 is going to be 20? Well, back in kindergarten, we learned that 4 plus 16 is 20. And so I know the small square has an area of 4. Now, if I went ahead and expanded this square, sorry, I'm trying to actually make it a square. Close. And I label this with an area of 4. How do I find the side lengths? This is the focus of today's lesson. And so in my mind, I am thinking, well, what times what is 4? And I think, well, of course, it's 2. I know that 2 times 2 is 4. I know that 2's square is 4. This is the prior knowledge that you need for today. So let's go ahead and dive into our first real problem for today. We have a perfect squares list. I want you to notice that the reason why we are able to find this square is because 4 is a perfect square. I know that 2 times 2 is 4. So here we have a list of perfect squares, and I ask myself, what times what? What times what is this row? Well, I know that 6 times 6 is 36. So I'm going to go ahead and write down 6. I know that 8 times 8 is 64. So I'm going to write down the number 8. I know that 2 times 2 is 4. So I'm going to write down the number 2. I would like you to please complete this perfect squares list. Okay, welcome back. The difficult ones that you might not know, here we have 15 times 15 is 225. We have 14 times 14 is 196. And 13 times 13 is 169. These are kind of the atypical ones, but you should have the rest. So I want you to notice that was driving forward, multiplication. Today's lesson is about understanding how to go in reverse. To find the side length of a square with a particular area, you used an operation called square root. The square root symbol looks like this and is also called a radical sign. To find the side length of a square with an area of 81, you would write down the square root of 81 and you think, what times what is 81? Oh, 9 times 9 is 81. Therefore, the square root of 81 is 9. That tells me the side length is 9 on each side. So here's what we are going to practice in these next 4 problems. The square root simply means what times what is the number in the box. So what times what is 49? Well, you should think 7 times 7. Therefore, the square root of 49 is 7. Okay, 121. What times what is 121? You don't have to write that. This is what you are thinking. Well, I know that 11 times 11 is 121. Therefore, the square root of 121 is 11. This is a way of thinking about areas going to side lengths. I would like you to please find the answers to C and D. Pause the video now. Okay, let's go ahead and dive into our next problem. On your paper, you will just have this section, okay? And that's okay, but I'm going to do some additional writing up here that you do not need to copy. In problem 9-74, it was a homework problem that was canceled out. You tried to make a perfect square with 24 tiles and could not. Why was it not possible? Well, let's look at these rectangles off to the right-hand side. When you are making a rectangle, you are doing the area. I know that 1 times 12, or excuse me, Mr. McCoy, 1 times 24 is 24. I know that 2 times 12 is 24. I know that 3 times 8 is 24. I notice that 4 times 6 is 24. These are the multiples that make 24. And I notice that the further these numbers are away, it's a very long rectangle. The closer these numbers get, it becomes more of a square. Oh, it's so close to a square, but not quite. Now notice these are all the multiples. This is not a perfect square number. Notice this number, I can't say a whole number times a whole number is 24. I know that 4 times 4 is 16. I know that 5 times 5 is 25. There's nothing that makes a 24 here in the middle. So what do I do? Well, let's go ahead and record. Problem letter A. Why is it not possible? It is not possible because 24 is not a perfect square. Okay? If 24 is not a perfect square, what do we do? Okay? So letter B, here's what we are going to write. Now, I wrote these 2 numbers down for a reason. Because 24 is somewhere in there. So let's go ahead and record this. I know that the square root of 24 is between, notice how I wrote it, the square root of 16 and the square root of 25. Notice, it's between those numbers. I know that usually we like to read from left to right, but when we're doing these inequalities, I want you to focus on the center. We want to focus on, oh, the square root of 24 is between the square root of 16 and the square root of 25. Therefore, the square root of 24 is between what 2 whole numbers? Well, what was the square root of 16? It's 4. What was the square root of 25. It's 5. See, this is a way of thinking logically. You have to use what you know to figure out what you don't know. I know perfect squares. If I know perfect squares, I can find where the not perfect square is located. Problem letter C. Is the square root of 24 closer to one of the whole numbers than the other? Well, I noticed that 24 is really close to 25. Well, if it's really close to 25, that must mean something. Let's go ahead and write if the square root of 24 is really close to the square root of 25, we estimate square root of 24 is about, well, let's think. If the square root of 24 is between 4.0 and 5.0, where is the 24 in this spectrum? Is it close to 4.1, 4.2, 4.3, 4.4? Is it in the middle, 4.5? Or is it close to 4.6, 4.7, 4.8, 4.9? Well, here's the logic that should be going off in your head. If the square root of 24 is really close to the square root of 25, like really close, I am going to estimate that it is really close to this 5.0. What decimal is really close to 5.0? Well, it's 4.9. So I'm going to estimate that the square root of 24 is 4.9. Now, if I went ahead and grabbed a calculator and I said, well, how close is our estimate 4.9 times 4.9, 4.9. Well, if I multiplied that out, I'm going to get 24.01. That is really close to an estimate. That's like you go to the store and it costs $24.01. It's like, shoot, 1 penny off $1, that's no big deal. Half the time you could grab a penny out of the penny tray. It's so close. Now, if I wanted to find the actual square root, the exact answer is square root of 24 equals 4.898979 ... I think it's 486, but I'm not sure right now. It just eludes me. Here's what I want you to notice. This number goes on forever. That's why I wrote ... I want you to notice the decimal does not follow a pattern. This number is called irrational. We're going to talk more about irrational numbers in our next lesson. An irrational number is a number that goes on forever and does not have a pattern. Okay, but we can figure out the square roots as an estimate, like we did, but you're going to need a calculator in order to do the exact square roots. So here's what I want you to do before we tackle 9-84. Next to the graph, you have a graph that looks like 9-85. Over here, off to the right-hand side, you have a fairly large white space, and what I would like you to do is pause the video to record this list. Pause the video now to record this square roots list. Okay, so here's what problem 9-84 is asking. I'm going to focus on this, the square root of 40. So let's find the square root of 40. I'm going to write this in a different color, but first I want to work in the center of my two lists. Let's go ahead and scoot this over a little bit. There we go. Okay, where is the square root of 40? Well, if I look at my list, it's right there. The square root of 40 is right there. So how do I write it? Well, the square root of 40 is between the low side, square root of 36, and the high side, 49. Okay? And then I think, okay, so over here, if it's on this side, that means that the square root of 40 is between 6 and 7. That is today's task. Where is the square root of 40? Well, it's between these numbers. That is our task for today. So let's go ahead and do one more problem. Problem letter B is the square root of 95. On your square roots list, draw an arrow. Where is the square root of 95? You should have said right here. Okay, so how do we write our answer? Well, what's the square root below and what's the square root above? Go ahead and write what is the square root below and what is the square root above. You should have written 81 and 100. Okay, so where is the square root of 95? Well, if I know that it's above the square root of 81, 81 is 9. The square root of 100 is 10. I know that the square root of 95 is between 9 and 10. This is the skill that I need you to do today. I need you to be able to estimate square roots by telling me where is it. Okay, that is the goal for today's lesson. When we have this, here's what this is saying. Every time you are doing a square root, if you had a square and I knew that I have an area of 24, I recognize this is not a perfect square. This is something that I would have to estimate. Once we get good at this, we're going to say, oh, I know that the square root of 24 is between these two numbers. If it's between 4 and 5, I know that it's really close to that. I am going to estimate the side length 4.9 and 4.9. This is why we are doing today's lesson, because to understand square roots, you have to understand that you are going from an area 24 to an estimated side length of 4.9. Okay? Square roots help us find a side length. That's what we're doing. Okay, we are estimating side lengths so that we can do the upcoming lessons. Thank you for coming. I have one more problem. My apologies. One more problem. In chapters 7 and 8, you examine the graphs of various relationships. What would the relationship between side length and the side length of a square and the area of a square look like? So notice you have a table off to the side, and we have a couple points, 0, 0, blank, 24. Oh, we know what that number is. because we just found the estimate of 24 to be 4.9. So there's one number. Now, the area of a square, that is saying, what is 1's square? Well, 1 times 1 is 1. What is 2's square? Well, 2 times 2 is 4. You are going to complete this table, and then you are going to graph this on the graph paper. Please notice that how it is counting. We're counting by ones on the left, but the whole numbers are spread out on the x-axis. So 0, 0, 1, 1, 2, 4. You're going to notice that this is not a linear relationship. You need to go ahead and graph this very carefully. And I know that the directions here are asking for this. And what we're going to do with this graph in a later lesson is come back and see if this is a helpful tool for estimation. Okay. Oh, I know 4 point. Yep. Okay. Thanks for coming to today's lesson, estimating and understanding square roots. We'll see you next time.